Input is nothing but what? Here it has to accept at least one or more input. So then only by taking that input, it is able to produce the result. And we have a same problem and we have multiple way of solving that problem. This analysis of an algorithm or a performance analysis will going to help us in order to choose the best one here. When we wanted to start or to stop an execution of any of the algorithm, here it requires some of the computer's memory in order to complete the task of an algorithm. Everybody, a warm welcome to one and all. Welcome back to the session 3 of chapter 1, and we are in the unit 1 of B.C.A. second semester and a subject called Data Structures Using C. And I'm Rohini TS, lecturer, Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So in our today's session, we shall discuss about this algorithm. So now we'll see about the recap. That is what we have discussed in our last session. So that I have discussed regarding the dynamic memory allocation. So in the memory allocation, we have two kinds, right? So it is of static as well as the dynamic memory allocation. And also I have discussed regarding the memory allocation and deallocation functions, that includes malloc, calloc, realloc, as well as we have free. This static memory allocation will going to be takes place in the compile time, and dynamic memory allocation will going to takes place in the runtime. That is what you have to remember. And in order to give the specific amount of memory space for the program, and in order to give a same amount of memory space of all the blocks. So, and also we have discussed regarding what alteration of the memory allocation, whether I wanted to expand it or I wanted to reduce the size whichever allocated by making use of this realloc, and also in order to deallocate the memory space, then we have used this free function. So this is you have to remember when it comes to the memory allocation and deallocation function. So in our today's session, we shall discuss regarding the algorithm. So when it comes to the algorithm, here you have to remember one thing, what is the introduction part of an algorithm, why it is required, what do you mean by an algorithm, as well as what is its specification, that is what algorithm specification. And also we have a performance of an analysis, that means we are analyzing the performance of an algorithm based on certain criteria, and also we can measure the performance of an algorithm. That is what we are going to discuss in the next session, but as of now we'll discuss only regarding this algorithm specification as well as performance analysis. We'll get into today's session, that is regarding an algorithm. So before that, you have to understand one thing. So we have several kinds of problem in a real world entity, right? And in order to solve that problem, we are going to have a different methodologies. So when it comes to the computer science, we are going to use an algorithm. That is what we have a methodology, or it is a step-by-step process to solve a given problem. So it needs to be definite. That means it should not exceed more number of steps. Within certain number of steps, it has to give the resultant. So that it will going to be called as what? An algorithm. So first, I have to collect the requirements from an user, then it need to be analyzed. So after the analysis, we are going to write the requirement in the terms of analysis, or it will be in the terms of algorithm. So an algorithm is nothing but it is a step-by-step procedure to solve a given problem. It is we are representing the solution in the terms of step-by-step procedure, and each step should lead or it should yield certain result. Then we can say that the algorithm whatever we have written, that is efficient and it will be more effective to solve the given problem. So now we'll see the definition. An algorithm is a finite set of instruction. It must be finite. For example, if I wanted to add two numbers, like I wanted to perform addition of two numbers, let me consider that as sum is equal to a plus b. So in order to find this, an algorithm should not take more than 5 or 4 lines of a code. So it should not take 100 or 200 lines of code to solve the simple problem. That means it must be finite. Within certain amount of steps, it has to produce the resultant, so that if it followed, then it will going to accomplish a particular task. Why we are writing this algorithm? Mainly to solve a particular problem. problem, right? So that solution will be the step-by-step procedure, and all those steps needs to be finite. Then we will be calling that function or methodology as an algorithm. And also, an algorithm must satisfy the following criteria. That means we are specifying the algorithm. So, if I say or if I consider anything as an algorithm, what must be its specification? So, first specification is regarding input. So, input, as well know that input, processing as well as output, right? First it has to accept the input, then it has to do the processing, and at last it has to give the resultant. So then here algorithm is also needs to be specified with a certain criteria. First, it must take the input from an user. If I wanted to solve any of the problem, then it has to take the input, right? So that input is nothing but what? Here it has to accept at least one or more input. So then only by taking that input, it is able to produce the resultant. So it has to take 0 or more quantities that externally supplied. We have to give the input from outside, then it will be reached to the computer, then it is able to process the solution. And also output. So after taking the input, processing will going to take place, or a calculation part will be done. After that, it has to give the resultant. So that is what we are calling that as a output here. At least one quantity is produced. So here it has to produce at least one resultant. So it should not be null or it should not be nothing. It has to give certain resultant after taking the input and after doing the processing of that input. And here we have a definiteness. That means each instruction is clear and unambiguous. Here unambiguous in the sense what? It is confusions free. So if I consider sum is equal to a plus b, what it mean? It's directly say that we are adding two values like a and b we are adding, that will going to be stored in sum. It is very clear. And if I am going to write subtraction, sub is equal to a minus b. So here we are doing the subtraction, and that means what? An algorithm, whatever the steps we have, each step needs to be very efficient and it has to be clear and it should be confusion free. Then only it will be easy for the designer or a developer or to implement the system by taking the help of this algorithm. That is what? Definiteness. And also it includes finiteness. So as I told, if I wanted to add two numbers or if I wanted to subtract two numbers, at the time we know that it will take the input first. First it has to start, then it has to take the input, then it has to addition of two numbers has to take place. After that, it has to display the resultant. At last, we are going to do the stop of an algorithm. So, only it requires 5 lines of code, or only it requires only 5 steps in order to solve that addition of two numbers or subtraction of two numbers. So, when it comes to the finiteness, if I am finding the solution for any of the problem, it should not exceed or at certain stage or after certain steps, it has to be stopped. That means the solution whatever we are getting in terms of algorithm, it should be finite in numbers. So then we can say that it is efficient. And also we have a effectiveness. So effectiveness in the sense what? We have more number of algorithm, like I can solve the same problem with different kinds of algorithm, or I can write the solution in the different methodology. Effectiveness in the sense what? Every instruction must be a basic enough to carry it out. At each level or each step should yield certain result. So it should not be dumb and it should not be any wasteful thing. Each level should be easier and it should be clear and it must reach to the resultant as soon as possible. So effectiveness, it should not be complicated. It must be easy. So it must help to reach the resultant as soon as possible, so that it is also needs to be feasible. It is needs to be possible to implement or to find the solution for particular problem. So, hope you all understood regarding the specification of an algorithm. First, it has to take the input, 0 or 1 or more input has to take place, and after taking the input, it will going to process, then it has to produce at least one output here, and also this needs to be in the definiteness. That means it must be clear as well as unambiguous. And also we have a finiteness here, within certain number of steps, the resultant needs to be yield, and also we have a effectiveness here. So effectiveness in the sense what? It must help us to reach the solution as soon as possible. Along with that, it has to tell us whether it is possible to implement or not. So these are the things, or these are the specification of an algorithm. I hope you all understood. Let me move to the next concept, that is regarding the performance analysis or analysis of an algorithm performance. So as we all know that we are all going to use this algorithm methodology. That means we are using this step-by-step procedure to solve a problem. Then already I told you the way or a perspective whatever we have will be different from person to person, or it will be different from developer to developer. So here when we have certain problem, or when the real-time problem needs to be solved with the help of this algorithm, in the computer science we have different kinds of algorithm solution, or we have different way of writing the solution with the help of an algorithm. So that out of that we have to find which is the best solution, or which is the more effective and efficient solution to solve a same problem. For example, if you have a road, or if you wanted to reach some destination, at the time how we are going to reach the destination, we will be always searching that which is a shortcut, which will be more efficient and which is more convenient. In the same way, here also in the algorithm we have to find out which is the more efficient way of doing the solution or getting the solution for a same problem. So we have to choose a best solution, or we have to choose the best one to produce the resultant of a given problem. So that this performance analysis will going to help us in order to select the best algorithm from multiple algorithms to solve a problem. So if we have a same problem and we have multiple way of solving that problem, this analysis of an algorithm or a performance analysis will going to help us in order to choose the best one here. So that you have to remember. So when we have a multiple alternative algorithm, at the time we have to do the comparison from one algorithm to another algorithm based on certain criteria. So which will feel that it is more efficient for this solution of a problem, then we have to go with that. That is what we are going to call that as a performance analysis. So here you can see the definition of a performance analysis. So performance of an algorithm is a process of making evaluate judgment about the algorithm. So we are judging the algorithm based on certain criteria. It has to give the resultant as soon as possible, as well as it needs to be very clear and unambiguous, and it must be finite in number of steps. And also performance of an algorithm means predicting the resources which are required to an algorithm to perform its task. So here you have to remember a word called resources. Here we are predicting, or we are checking what are the resources it requires. When it comes to the resource, it will be time as well as the space, because processor time is more efficient and processor time is very precious in the analysis of a algorithm. And what is the memory space it required? That is also going to be a very important thing. So that analysis will help us to predict all these time as well as the space which is required in order to solve a given problem. And also when we have multiple algorithms to solve a given problem, there you have to select the suitable algorithm. Then we have to make a comparison from one algorithm to another algorithm. Then only we can choose the best one here. And also when we are comparing all those whatever the algorithm which is available to find the solution, there we have to have certain parameters, like it will going to include what is the memory it required by the algorithm. Along with that, we have to think about the execution speed of an algorithm and whether it is easy to understand and whether it is easy to implement based on certain criteria or based on certain steps or rules and regulation. Then we have to choose the best algorithm to get the solution for a given problem. So now we'll see what are the elements we have in order to check the analysis of a performance. Like for example, if I have 5 solutions, or if I have a 5 different algorithm to solve a same problem, at that time how can I choose the best one? Then after choosing that as the best one, then I have to justify this is the best among all those 4 or all those 5 in order to meet certain requirements. So here we have certain requirements or certain elements. So So by using these elements, I can say that the algorithm whatever we have chose for the solution of an problem is efficient as well as effective. So what it comprises of then? Whether the algorithm is providing the exact solution for the problem. So here we have to check whether it is providing an exact solution for the problem, or it is just simply touching the solution of a problem, or do we getting only alternatives for the problem. So we have to check whether it is exact solution of a given problem. So if it is yes, then you can choose that algorithm to solve your problem, and whether it is easy to understand. So when we are writing an algorithm, at that time it must be easy to understand. So if it is of complex, which is very ambiguous, or which is full of confusion, then I'm not able, like developers or a programmer somehow will not be able to convert that into some designing part. After that designing, coding has to take place. So algorithm whatever we are going to write needs to be very easy, and it should be clear and easy to understand. So if it is yes, then we can proceed that algorithm, and also whether it is easy to implement. So after writing the algorithm, we are writing it in a theoretical aspects or a theoretical form. So after that writing, it has to be converted into some diagrammatic representation. After that, it has to be implemented. So that is what we are doing the coding. So when we are writing an algorithm, it has to be easy enough to develop that system with the help of implementation. So that aspects or that element is also required when I wanted to choose a best algorithm. And also how much space or a memory it requires to solve the problem, as well as how much time. So these two will going to be very important. So mainly we require a memory space, whatever we have in a computer memory. So if I wanted to implement it, it has to be in the primary memory. So whatever the memory space it requires in order to solve that problem, as well as what is the time it requires in order to solve that problem. So these are the criteria, or these are the specification of a performance of an algorithm. So if an algorithm is satisfying, or whatever the written algorithm we have for as a solution for the particular problem, so if it is reaching all these elements, then we can choose that algorithm to solve a particular problem. So that mainly performance analysis of an algorithm is the process of calculating the space as well as the time which is required by that algorithm. So mainly we have to focus on two things. One is time as well as space. So here performance analysis of an algorithm is performed by following measures. So that if you are working with the space of an memory of a computer, then we are going to call that as a space complexity. That means the space required to complete the task of that algorithm. So after the initialization of that algorithm, and to reach the end or to reach the completion of a algorithm, how much space or a memory that we require. So that is considered as what? Space complexity. And also we have that space complexity also includes regarding the space of program space as well as the data space. So both the space will be considered together in order to complete the task of a solution, to find a solution of a given problem. So in order to do all these procedure, what is the space or a memory required will be considered as what? Space complexity. And also we have a time complexity. So as the name indicates, time in the sense how much time it required, whether it how efficient it is to give the resultant of an algorithm. That is time required to complete the task of the given algorithm. Then we can say that as a time complexity. So when I'm telling that, or when we are saying this algorithm is efficient in order to give a solution, it has to satisfy mainly two criteria. One is with respect to space complexity and another one is with respect to time complexity. So now we'll see about this space complexity. Already we know about the space complexity, like how much space or a memory it required in order to complete the algorithm. So here when we design an algorithm to solve a problem, it needs some computer memory in order to complete its execution. Already we know that when we wanted to start or to stop an execution of any of the algorithm, here it requires some of the computer's memory in order to complete the task of an algorithm. So for any of the algorithm, memory is required. So if I wanted to run or if I wanted to implement any of the algorithm to solve a problem, then it requires the computer memory. For what reason it is requiring? We'll see now. So mainly to store a program instruction. So when we have a algorithm, we are going to write a step-by-step procedure as a solution, and that is a instruction. So in order to store that instruction, we require a computer memory as well as to store the constant values. So in order to store a constant values, for example, we have a pi, so that value won't get changed throughout that period. So that in order to store that kinds of constant values, we require memory space, and also in order to store the variable values, functional calls, whether it is a jumping statement or any other looping statement, if you are using in a program, then it requires a computer memory. So in order to hold the information regarding all these things, we require a computer memory. So this is regarding space complexity. We'll see about the time complexity now. So here it is the time required in order to complete an algorithm. That is what every algorithm requires some amount of computed time. That means we are talking about the processing time or a processor time. So that in order to execute its instruction to perform the task, so the computer time required is called as time complexity. What is the computer time or its processor time that we are using in order to solve a problem? Then we are going to call that as a time complexity. And this time complexity can be defined in another definition, that is time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. Mainly to complete the execution of an algorithm, we require some of the processor time. So that time is considered as what? Time complexity. So what would you like to say? Whether time complexity needs to be high or a low? It has to be low, because if the processor speed is high and its computing speed also will be high, so we are going to get the resultant within a short period of time. So that time complexity needs to be reduced, and even space complexity small or should be reduced. So if we have a space and time complexity, or if we are managing that time and space complexity in an efficient manner, then it will be easy to analyze the performance of an algorithm. And also this time complexity will going to be determined, or the running time of an algorithm will going to be checked in by making use of certain following criteria. Like, how can I say how much time it require in order to solve or to complete the solution of an algorithm? So here we have to consider whether it is running on a single processor machine or a multiple processor machine. I have to check about the type of processor we are using, whether it is a single processor or a multi-processor machine. So based on that also we can check the time complexity, and also we have to worry about its size or a memory space. So here whether it is a 34-bit machine or a 64-bit machine, based on the processor speed we are checking, like how efficient it is, whether it is a 34-bit or a 64-bit, and also what is the amount of time it is taking for the operation of read and write. So whether we are copying the content from a memory to program or a program to memory, so that defines the read and write operation. So in order to do that operation, how much time it is taking by the machine, so that specifies the speed of a machine. And also it depends on the input data. For example, if I am adding only 2 numbers, whether I am adding 10,000 numbers, so that is also depends on the input data what we are giving. And also the amount of time required by an algorithm to perform arithmetic operations or any of the operations that includes logical operations, and what is the time it is taking in order to return a value for a particular function, and also what is the assignment operation is doing. Like if you are performing any of the operation, how much time it is requiring in order to do all those things will going to be define the run time of an algorithm. So if it is less, then we can say that this algorithm is effective as well as efficient. So these are the things you have to remember when it comes to the time complexity. I hope you all understood. So it's all about our today's session. In my coming session, we shall discuss regarding the performance measurement of an algorithm itself, and also we'll see the new topic called recursion. So we'll discuss in the next class. Until that, keep learning, keep on growing. Thank you.